This is Veer Brahmacharlu presenting on behalf of a team consisting of Mr. Ganesh Shetty, Sudhakar, Ankit Das, Nasim Obaid, and Ms. Sinchana. This is the process flow of JSW Steel Vijayanagar Works. The raw materials, that is iron ore, flux, and coal, are processed to produce sinter, pellet, and coke. Sinter, pellets, and coke are charged in blast furnace to produce hot metal, and pellets are charged in DRA shaft to produce DRI. The steel scrap, hot metal are charged in basic oxygen furnace to produce liquid steel. The steel scrap and DRI are charged in electric arc furnace to produce liquid steel. The liquid steel is cast in continuous casting machines to produce slabs and billets. The slabs are rolled in hot strip mill and cold rolling mills to produce flat products. The billets are rolled in wire rod mill and bar rod mills to produce long products. The byproduct gas generated from coke oven, corex, blast furnace, LD, and DRI are mixed is called mixed gas. The mixed gas is used for various heating applications in the entire integrated steel plant. This is the roadmap for decarbonization consisting of renewable energy, green hydrogen based steel making, carbon capture, utilization, and storage. Here is the strategic plan to reduce the current CO2 footprint from 2.5 tons to zero point 0.8 ton per ton of crude steel. Our incremental decarbonization initiative, SEED, stands for Sustainable Energy, Environment and Decarbonization. This is the dashboard to monitor CO2 footprint. There have been several quality improvement programs through SEED. Our case study, injecting coke oven gas into the sinter bed, showcases improvement in CTP, critical to process. We also improved the production and CTQ, critical to quality. These are the technology, energy efficiency, environment, quality, and sustainability milestones. The idea is to substitute the fossil fuel partially by coke oven gas. This is the overview of the sinter plant showing the location of the COG injection system. Here is a brief introduction to the sintering process. The pilot trials began in 2019 using Sinterpot facility. It did not have arrangements to inject gases, so we introduced gas injection system and conducted trials. The product center was dense, had higher strength, and better elevated temperature properties. Due to parametric interplay, which is inherent to sintering process, the alpha in the design of experiment showed 1.4. Oxygen, which can improve the combustion efficiency of coke, and liquefied petroleum gas (LPG) as an alternate gaseous fuel were injected to see their effects. The coke oven gas has about 57% hydrogen, a carbon neutral source of heat and reductant of the iron ore. When injected, COG outperformed LPG. Hydrogen in the COG enhanced FeO formation. Superior mineralogical phase assemblages were noticed, which resulted in enhanced properties of the sinter. The voice of the process indicated improved thermal regime and mineralogy. After proving the concept, we scaled up by designing COG header, nozzles, and installed in Sinter Plant 4 in 2020 during COVID times. This is the scheme of the injection system. The design involved three headers of 150 cubic meter per hour capacity, each and nozzles to inject COG close to the sinter bed. Multiple trials were conducted to fine tune the process, and we continued injecting for more than 1.5 years. Sinter plant 2 and 4 consume the base mix from a single source. With COG being injected, sinter plant 4 consumed less coke, as seen by the coke run chart. The tumbler index and suction increased due to COG. Analysis of variance shows the process capability of FEO increased from 0.27 to 0.35. After successfully proving the industrial scale concept, the COG injection system was installed in Sinter Plant 3, which is double the capacity of Sinter Plant 4. Data analysis of Sinter Plant 3 indicated higher tumbler index and process capability. In both Sinter Plant 3 and 4, the elevated temperature property RDI remained unchanged. Hypothesis testing confirmed that the sintering process is not delayed due to prolonged thermal regime. Exponentially weighted moving average confirmed an increase in production of 800 tons per day, that is about 6%. With this improvement, it is possible to save about 30 Indian rupees per ton of sinter or 2.3 million Indian rupees per annum directly. Thank you.